So the new thing here, you know what functions are, right? So functions are graph that graphically they pass the vertical line test, right? So we've encountered parabolas, we encountered root functions, we encountered, right, reciprocal functions, right? And things like circles, you know, it's not a function, right? Okay. So we want to discuss a new type of function called periodic function. Now, periodic functions are, as x moves forward, as x gets larger, the y values, okay, form a pattern. So for example, so like it went up and down to 0, right? Up and down to 0, up and down to 0. It's forming a pattern, right? Such functions are called periodic functions. Okay, so this is going to be important for like studying in physics, like waves, right? A lot of things, or a lot of data like repeats itself. Even history repeats itself, right? So a lot of data are, or they get naturally organized in this way. Okay, so these are called periodic functions. So it doesn't have to look like this. It could be really anything. It could be like this, like that, and then go this, like that. Like anything that repeats, like it has a clear visual pattern. It's a periodic function. Now, let's say it took here this to be 3, 6, right? And this is 9, right? We call this here, how long from beginning to end to finish one pattern, the period. So the period of this function is 3. Does that make sense? Okay. And then we also say the amplitude. So usually the amplitude, okay, so you're going to see that you've just finished trig. The sine function looks like this. Okay. So the amplitude is referring to from the middle of the graph. Okay, this sine function is actually symmetric, both top and bottom. It's the same shape, just flipped upside down. And from the middle, okay, from the middle to the top is called the amplitude. Amplitude, like that. Okay, so if let's say this is the height of 2, the y value is 2, the amplitude equal to 2 here. So if I wanted to draw a periodic function with amplitude of 5, right, and let's say the period is 4, this is what it will look like. Here's 5, so it'll go up to 5, come back down, also 5, it'll finish by 4, and this pattern won't have to repeat. Make sense? Okay. The other term here is equation of axis, okay? This is referring to the equation of the horizontal line that cuts the periodic function in half. Okay? So this we use this term because now we want to, if we want to shift this graph up, we need to label that something, right? So let's say the same graph, I want to shift it up by 3. So equation of axis is 3. Right? It has to have amplitude of 5, so it'll go up to 8, right? So it'll go up to 8, and it'll have to come down to -2. So this has an amplitude of 5 because it starts from 3, goes up to 8, okay? Goes down to -2. Period of 4 because it'll finish at 4. And the axis, equation of the axis is equal to y equals 3. Okay, does that make sense? Just like any functions, if the graph ended here, we will say the domain is x is real value such that x is from 0 to, let's say, oh sorry, not 4. 4 should be here because that's where the finish is, right? 4, and the range in this case is from -2 to 8, right? So we say y is all real value but y is in between -2 to 8. Okay. So sometimes I would ask you, find a sketch or find the periodic function which has this as your domain, and this as your range. And usually, let's say like the period finishes in this domain, or you'll have two periods. Okay. So for example, if I say in here I want two periods instead of one period, then you'll have to cut it in half. And I'll have to draw the graph like this instead. Like 1, 2. Does that make sense?
Yeah.
Okay.